All right, let's continue our look at the final review. We're now going to look at pages 2 through 4, problems 5 through 9. So let's go ahead and get started. Okay, the next problem we're going to look at is problem number 5. We have tables of values and scatter plots for 3 functions. The first thing we want to do is we want to identify whether the function is linear, exponential, or quadratic based on the graph. So note that we have two ways to represent the data on each function. So for instance, if we look at function f of x, we want to know whether this is linear, exponential, or quadratic. And f of x is an exponential function. Notice that it levels out on the bottom before going up really quickly. That's our basic exponential shape. If we look at h of x is linear. It is going down at a constant rate. And the last one is easy to identify because it has that up and down shape. This is quadratic. Notice that it has a maximum point on our graph. Okay, the next thing we want to do, if the function is linear, we want to find the slope. So to find the slope, we're going to look at the table. And what we want to do is we want to figure out what is the rate that it is increasing or decreasing as we go down the table. If we look at this, to get from 9 to 6, we subtract 3. 6 to 3, we subtract 3. And all the way down the table, we do the same thing. So our slope is -3. All right, that takes care of linear. The second option we have, if the function is exponential, we want to find the base multiplier. And the base multiplier is similar to the slope, except for instead of adding or subtracting, we're going to be multiplying. So for instance, on my exponential function, how do we get from 6 to 18? We multiply by 3. 18 to 54 is the same thing. 54 to 162. All of these are going to be multiplied by 3 as we go down our table. So our base multiplier b is equal to 3. And finally, the last one we have, if the function is quadratic, we want to find the vertex. So when we look for vertex, what we are looking for is the maximum point. So for instance, if you notice here on opposite sides of 2, 7, we have our symmetric points 1, 6, and 3, 6. We also have our symmetric points 0, 3, and 4, 3. We are looking for where those y coordinates are the same. And then what we are looking for is what happens is where is the middle of these things. And so our middle point is 2, 7. That is your vertex. All right, let's go ahead and continue on. The next thing that we have is we have a graph, and we are going to want to answer some questions involving the function. So if we look at this, it says estimate f of 1. F of 1, remember that if the number is inside the parentheses, it is an x value. So I am going to come over to where x equals 1 and find where my graph is at that point. This is the point that we are looking at, and we have f of 1 is equal to 20. The other one we have is f of x equals 10. Remember that if it is outside, it is a y value. So I am looking for where y is 10, and we want to estimate the x value. Our x value is 2. For C, we want to find the vertical intercept. So which line is the vertical line? It is going to be the y. So where does this intercept the y-axis? It happens at 0, 40. Make sure that you record your answer as a point. All right, for part D, we want our domain and range. For our domain, we want to know how far left does this go. This arrow continues going forever to the left, so this is negative infinity. This arrow continues to the right forever. This is positive infinity. The other thing to note is that this is an exponential graph. And remember that all exponentials have domain of negative infinity to positive infinity. For our range, this does not, if we go from bottom to top, this does not keep going down forever. It is getting closer and closer to 0. But does not touch 0. So my lowest number is 0 with a parenthesis, and my graph, how far up does it go? Because we have an arrow there, it goes up to positive infinity. All right, that takes care of number 6. Let's look at number 7. So for number 7, we want to estimate f of 5. Again, remember that if 5 is inside the parentheses, this is an x value. So we're going to come over to where x equals 5 and determine the y-coordinate. My y-coordinate is 2. For part B, we want to estimate the x values that make f of x equal to 1. So 1 is a y value. So what are we looking at there? We are looking at this point as well as this point here. We get x equals, does say estimate, so we can go ahead and go out to maybe one decimal place. Let's say 4.7 and 9.3. Again, these are estimates because it does not cross through a nice coordinate there. Okay, so if you have 4.8 and 9.2, that's all right. Okay, for D, we want to estimate the horizontal intercepts. Which one is the horizontal axis? That's the x. So where are we crossing on the horizontal axis? we are looking at these 2 points. Again, this is going to be estimates. So our horizontal intercepts are going to be, let's say 4.5, comma 0, and 9.5, comma 0. And the last thing we have is domain and range. So domain, we're going left to right. This arrow here goes forever to the left. This arrow here goes forever to the right. And so we are looking at a domain of negative infinity to positive infinity. For my range, we're looking at bottom to top. Both of these arrows go forever down. And so we have negative infinity. Our highest point is at 7, 6, and remember that we want to keep the y-coordinate when we are talking range. Range has to do with the y-coordinates. So we're going to go negative infinity to 6 and use a square bracket. All right, example 8. Again, we have a graph and we want to go ahead and calculate the evaluator function. So for example A, we have f of 9. Our 9 is an x coordinate. And it looks to me like f of 9 is equal to 4. 9 is going to be halfway between 8 and 10. And if we go up to where it meets the graph, we meet the graph at 4. For B, we have f of x equals 6. So where is this equal to 6? We are looking at the graph right here. So f of x equals 6. That means x is equal to 0 and 10. For part C, we want to estimate the horizontal intercepts. So we are looking for where y is 0. We're going across. We have these are our 2 horizontal intercepts. In point form, these are going to be 2, 0 and 7, 0. And for D, we want to talk about our domain and our range. So our domain, since we have our arrows at the end of our line segments, these go forever to the left and to the right. So our domain is negative infinity to infinity. Our range, we're going to go bottom to top, the y values. My bottommost y value is negative 6. And we go forever up. So my second thing in my interval notation will be positive infinity. For problem 9, we're going to be given an exponential function. And the first thing that we want to do is find the inverse. So remember that the inverse of an exponential function is a logarithmic function. So we're going to have f inverse of x equals log base 3 of x. Make sure that you include the inverse notation. Make sure it's f to the negative 1. All right, for the rest of this, for part B, we want to complete the table by evaluating our exponential function. So if we look at 3 to the negative 1, I want the reciprocal of 3, which is 1/3. 3 to the 0 is 1. 3 to the 1 is 3. 3 squared is 9. And 3 cubed is 27. From there it says use your knowledge of inverse functions to complete the last two columns. So remember that inverse functions, what we do is we flip our columns. So my f of x becomes my x column, and my x column becomes my f inverse column. So we get negative 1, 0, 1, 2, and 3. Last thing we want to do is go ahead and graph this. It says we want to sketch f of x and its inverse on the same set of axes and include the line y equals x. So my f of x, let's go ahead and graph that one first. We have, pick any 3 points you want. I'm going to go with the first 3. We have negative 1, 1/3, 0, 1, and 1, 3. If we sketch our graph, we get something that looks like this. F of x. Next one we want to graph is f inverse of x. So we get 1/3, negative 1, 0, 1, and 3, 1. And if we sketch our graph, it should look something like this. And finally, we want the line y equals x. And just remember that the line y equals x is a line going through the origin with a slope of 1. So this is what we get for our graph. All right, that takes care of problems 5 through 9. We'll go ahead and take a quick break, and then we'll come back and continue with some more of the final review.